Controller handling. The final and uppermost layer in the processing architecture is the controller handling. This layer is responsible for receiving a request message from the underlying pipeline and transforming it into a call to a controller's action method. Passing the required method parameters. It also is responsible for converting the method's return value into a response message and passing it back to the message handler pipeline. Bridging the message handler pipeline and the controller handling is performed by the controller dispatcher, which is still a message handler. Its main task is to select, create, and call the correct controller to handle a request. This process is detailed in Chapter 12, which presents all the relevant classes and shows how you can change the default behavior using the available extensibility points. The API controller base class, the concrete controller that ultimately handles the request, can directly implement the IP controller interface. However, the common scenario, as presented in the previous chapter, is for the concrete controller to derive from the abstract API controller class, as shown in Figure 4 to 5. It is the job of API controller.execute async to select the appropriate action, given the HTTP request method, e.g., GET or POST, and call the associated method on the derived concrete controller. For instance, the GET request in example 4 to 1 will be dispatched to the process's controller.getStringName method. Figure 4 to 5. Concrete controller deriving from the abstract API controller class. After the action is selected but before the method is invoked, the API controller class executes a filter pipeline, as shown in Figure 4 to 6. ACH action has its own pipeline composed of the following functionalities: parameter binding, conversion from the actions returned into an HTTP response message, authentication, authorization, and action filters, exception filters. Figure 4 to 6. Per action filter pipeline, parameter binding, and result conversions. Parameter binding is the computation of the action's parameter values, used when calling the actions method. This process is illustrated in Figure 4 to 7 and uses information from several sources, namely the root data, e.g., root parameters, the request URI query string, the request body, the request headers. Figure 4 to 7. Parameter binding. When executing the actions pipeline, the API controller.execute async method calls a sequence of HTTP parameter binding instances, where each one is associated with one of the actions method parameters. ACH HTTP parameter binding instance computes the value of one parameter and adds it to the action arguments dictionary in the HTTP ACH context instance. HTTP parameter binding is an abstract class with multiple derived concrete classes, one for each type of parameter binding. For instance, the formatter parameter binding class uses the request body content in a formatter to obtain the parameter value. Formatters are classes that extend the abstract media type formatter class and perform bidirectional conversions between CLR common language runtime types and byte. 2. The IP action result interface was introduced in version 2.0 of Web API. Stream representations, as defined by Internet media types. Figure 4 to 8 illustrates the functionality of these formatters. Figure 4 to 8. FO. Matters and conversions between message bodies and CLR objects. A different kind of parameter binding is the model binder parameter binding class, which instead uses the concept of model binders to fetch information from the root data. In a manner similar to ASP.NET MVC. FO. R instance. Consider the action in example 4 to 2 and the HTTP request in example 4 to 1. The name parameter in the get method will be bound to the value explorer, that is, the value for the query string entry with name key. We will provide more detail on formatters, model binding, and validation in Chapter 13. Conversion into an HTTP response message after the action method ends and before the result is returned to the filter pipeline. The action result, which can be any object, must be converted into an HTTP response message. If the return type is assignable to the action result interface 2 presented in example 4-3, then the results execute async method is called to convert it into a response message. There are several implementations of this interface, such as OK result and redirect result, that can be used in the actions code. EAPI controller base class also includes several protected methods not shown in figure 4-5 that can be used by derived classes to construct action result implementations, e.g., protected internal virtual OK result OK. Example 4-3. Action result interface public interface action result. Task. Execute async cancellation token. If the return isn't an action result, then an external result converter, implementing the action result converter interface as defined in example 4-4, is selected and used to produce the response message. Example 4-4. Res. ULT converters converting the actions return into response messages public interface action result converter. HTTP response message convert. HTTP controller context, object action result. For the HTTP request in example 4-1, the selected result converter will try to locate a formatter that can read a process collection state, i.e., the type returned by the actions method, and produce a byte stream representation of it in application/JSON, i.e., the value of the request's accept header. In the end, the resulting response is the one presented in example 4-5. Example 4-5. HTTP response HTTP/1.1200 OK cache control no cache pragma no cache content type application/JSON. Charset equals UTF-8 expires -1 server Microsoft IIS/8.0 date Thursday, April 25, 2013 115,012 GMT content length. Processes ID 2824, name Explorer, total processor time in millis 831,656.9311. Formatters and content negotiation are addressed in more detail in Chapter 13. Filters, authentication, authorizations, and action filters are defined by the interfaces listed in example 4-6, and have a role similar to message handlers, namely, to implement cross-cutting concerns, e.g., authentication, authorization, and validation. Example 4-6. F. Filter interfaces public interface iFilter will allow multiple get. Public interface authentication filter iFilter. Task authenticate async. HTTP authentication context. Cancellation token. Task challenge async. HTTP authentication challenge context. Cancellation token. Public interface authorization filter iFilter. Task. Execute authorization filter async. HTTP action context. Cancellation token. Func. Continuation. Public interface action filter iFilter. Task. Execute action filter async. HTTP action context. Cancellation token. Func. Continuation. Public interface exception filter iFilter. Task execute exception filter async. HTTP action executed context action executed context. Cancellation token. For authorization and action filters, the pipeline is organized similarly to the message handler pipeline. Each filter receives a reference to the next one in the pipeline and has the ability to perform pre- and post-processing over the request and the response. Alternatively, the filter can produce a new response and end the request immediately, thereby short-circuiting any further processing, namely, the action's invocation. Invocation filters operate under a slightly different model, as we will see in Chapter 15. The main difference between authorization and action filters is that the former are located before parameter binding takes place, whereas the latter are located after this binding. As a result, authorization filters are an adequate extension point to insert OP errata that should be performed as early in the pipeline as possible. The typical example is verifying if the request is authorized and immediately producing a 401 not authorized HTTP response message if it is not. On the other hand, action filters are appropriate when access to the bound parameters is required. A fourth filter type, exception filters, is used only if the task returned by the filter pipeline is in the faulted state, that is, there was an exception. Each exception filter is called in sequence and has the chance to handle the exception by creating an HTTP response message. Recall that if the controller dispatcher handler receives an unhandled exception, an HTTP response message with a status code of 500, internal server error is returned. We can associate filters to controllers or actions in multiple ways. Via attributes, similarly to what is supported by ASP.NET MVC. By explicitly registering filter instances in the configuration object, using the HTTP configuration.filters collection. By registering a filter provider implementation in the configuration services container. After the HTTP response message instance has left the action pipeline, it is returned by API controller to the controller dispatcher handler. Then it descends through the Sage handler pipeline until it is converted into a native HTTP response by the hosting layer. Conclusion. This chapter concludes the first part of the book, the aim of which was to introduce ASP.NET Web API, the motivation behind its existence, its basic programming model, and its core processing architecture. Using this knowledge, we will shift focus in the next part to the design, implementation, and consumption of evolvable web APIs, using ASP.NET Web API as the supporting platform. Chapter 5: The application.